Here's a question that sounds so simple it almost feels like a joke, and yet it has tripped up some very smart people. Stand in front of a mirror and raise your right hand. The person staring back lifts what looks like their left. Write a word on a sheet of paper, hold it up, and suddenly the letters appear reversed. So we say, mirrors flip left and right. But here's the puzzle. If mirrors really swap left and right, why don't they also flip you upside down? Your head is still at the top, your feet are still at the bottom. How does a silent sheet of glass decide which directions to change and which to leave alone? By the time we're done here, you'll know exactly what's happening, and the answer will feel so obvious you'll wonder how it ever seemed mysterious. Because the explanation isn't complicated physics at all. It's a beautiful example of how our brains quietly insert assumptions into what we think we're seeing. Let's begin with what we believe we observe. You face a mirror and wave your right hand. The reflection appears to wave its left. From that, we conclude the mirror has swapped sides. But physics demands we check that assumption carefully. So let's set up directions like a physicist would. Imagine you're facing north toward the mirror. Your right hand points east. Now look closely at the reflection. Where is that hand? Still on the east side. The mirror hasn't swapped east and west at all. Your right hand and the reflection's right hand are in the same place in space. So what changed? Here's the crucial insight. Mirrors don't reverse left and right. They reverse front and back. That's the only direction a mirror knows how to affect, the one perpendicular to its surface. Your nose points toward the mirror. In the reflection, it points away. Your back faced away. In the reflection, it faces toward. That's the transformation. Nothing more. Left and right stay untouched. Up and down stay untouched. Only the direction pointing into or out of the mirror flips. So why are we convinced left and right swapped? That's where the interesting part begins. And it's not about optics at all. It's about us. When you look at your reflection, your brain instantly interprets it as another person facing you. And your mind performs a little mental trick without asking permission. It imagines what would have to happen for a real person to stand where the reflection is. To face you, they would have to rotate around and turn 180 degrees. And that rotation really would swap left and right relative to you. But the mirror image didn't rotate. It didn't spin around. It underwent a different transformation entirely, more like turning a glove inside out than turning your body around. And that difference between inversion and rotation is the heart of the puzzle. Let's test this with something simple. Take a clear sheet of plastic or paper and write a word on it. Hold it so you can read it. Now place it in front of a mirror without turning it around. The reflection shows the back of the sheet, and the word looks perfectly normal. But now rotate the paper to face the mirror. Suddenly, the letters look reversed. The mirror didn't change anything. You did. You performed the rotation that swapped left and right before the mirror even got involved. The mirror simply shows whatever orientation reaches it. It always flips front and back, nothing else. Another way to picture this is to imagine yourself as an arrow pointing toward the mirror. In the reflection, that arrow points back toward you. The depth direction reversed, but the sideways direction stayed exactly where it was. The apparent left-right swap isn't something the mirror does. It's something our interpretation creates. And once you see that, the mystery starts to dissolve. To really feel what's happening, imagine something even more dramatic than a reflection. Imagine you could somehow turn yourself inside out the way you pull a glove through itself. Your chest would become your back, and your back would become your chest, yet your left arm would still be on your left side, and your right arm would still be on your right. That strange inside-out transformation is actually much closer to what a mirror does than any kind of rotation. Here's a simple experiment you can picture. Take a transparent sheet and write a word on it with a marker. Hold it so both you and a friend can look at the same side while facing each other. One of you will read the word correctly, while the other sees it backward. Nobody reversed anything. You're just viewing the same object from opposite sides. A mirror works like a magical window that lets you see the front of yourself as if you were somehow looking from behind, without ever moving there. That's the key. The mirror doesn't rotate you. It gives you a view you normally can't have, like seeing your own face from the outside. This becomes even clearer if you imagine a right-handed glove. Try to transform it into a left-handed glove using only rotations and flips in space. You can twist it, spin it, and tumble it all you want. It never becomes a left glove. The only way to convert it is to turn it inside out. That operation swaps what was facing inward with what was facing outward, and suddenly the glove fits the other hand. Mirrors do the same conceptual trick. They invert depth, not sideways direction. Now think about something familiar, like a wedding ring. Suppose yours is on your left hand. In the mirror, where is it? Still on the same side of your body in physical space. But your brain insists that the reflection is another person facing you. And if that person's ring is on the side matching your left, then it must be their right. That interpretation creates the illusion of a swap. The mirror itself didn't move anything. Here's a fun test. Stand with your back to a mirror and glance at the reflection over your shoulder. Notice how the left-right confusion almost disappears. That's because you're no longer imagining someone facing you. You're just seeing a figure from behind. Without the imagined rotation, the illusion fades. This also explains why the word ambulance is printed backward on the front of emergency vehicles. It's not that mirrors magically reverse letters. The word is deliberately printed as a mirror image so that when your rearview mirror flips front and back, the letters end up readable. If you hold a word in front of a mirror without rotating it, it reads normally. It's our habit of turning objects to face the mirror that creates the sideways reversal we think we're seeing. There's another subtle reason this puzzle fools us so easily. Human beings are almost perfectly symmetrical from left to right. Because of that symmetry, when we see a reflection, our brains instinctively try to match it to a real person. And the only way to match it to a real person standing where the reflection is would be to imagine them turning around. That imagined rotation introduces the left-right switch. If we weren't symmetrical creatures, the confusion might never arise at all. Picture a creature with wildly different shapes on each side of its body. It wouldn't need to imagine any rotation to interpret its reflection. It would instantly see that only the front and back had changed. The puzzle is really a quirk of how human perception works, not a mystery of optics. And once you realize that, the mirror stops being magical and starts being beautifully simple. It only flips the direction pointing into it. Everything else stays exactly where it was. But now the story takes an interesting turn, because physicists eventually asked a much deeper question. If mirrors don't really swap left and right, does the universe itself even have a true distinction between left and right? Or are those directions just conventions we invented? For a long time, scientists believed the laws of nature treated left and right as perfectly equivalent. But then something astonishing happened that forced them to rethink that assumption entirely. For decades, physicists believed something very elegant about the universe. They believed nature didn't care about left and right at all. This idea was called parity conservation. In simple terms, it meant that if you built a perfect mirror image version of any physical experiment, it would behave exactly the same way. The mirror world and the real world would follow identical rules. Left-handed systems and right-handed systems would be indistinguishable to the laws of physics. It was a beautiful idea, and beauty has a way of making us comfortable. So comfortable, in fact, that hardly anyone thought to test it carefully. Then, in the 1950s, two physicists named Tsung-Dao Lee and Chen-Ning Yang noticed something odd. There were particles that seemed identical in every measurable way, yet they decayed into different combinations of other particles. This inconsistency didn't fit the assumption that parity was always conserved. Instead of forcing the evidence to match the theory, Li and Yang asked a bold question. What if parity wasn't conserved at all in certain interactions? What if nature did distinguish left from right at the most fundamental level? It was a radical idea, because it challenged a principle many physicists had treated almost like a law of symmetry in the universe. But science advances when someone dares to check what everyone else assumes. Li and Yang proposed an experiment to test it, and that experiment was carried out by the brilliant experimental physicist Chien-Shiung Wu. Her work would become one of the most important demonstrations in modern physics. Wu took atoms of cobalt-60, cooled them to extremely low temperatures, and aligned their nuclear spins using a magnetic field. When these nuclei undergo beta decay, they emit electrons. If parity were conserved, those electrons should fly off equally in all directions. The mirror image of the experiment would look identical. But that's not what happened. Wu found that more electrons emerged in one direction relative to the spin than the other. The mirror image of the experiment would produce a different result. Nature, at least in weak nuclear interactions, actually prefers one-handedness over the other. This discovery shocked the physics community. The universe, it turned out, does distinguish left from right after all. Li and Yang received the Nobel Prize for the theoretical insight, though Wu's experimental contribution was just as crucial. It remains one of the great turning points in our understanding of symmetry in nature. Now, you might wonder what this has to do with mirrors in your bathroom. The answer is subtle but fascinating. Even though the weak nuclear force breaks left-right symmetry, the forces we encounter in everyday life, gravity, electromagnetism, and the strong nuclear force still behave symmetrically. So at human scales, mirrors continue to behave exactly the way we described earlier. They flip only the direction perpendicular to their surface. Our brains supply the rest of the interpretation. But the Wu experiment revealed something profound. In principle, you could define an absolute left and right anywhere in the universe. If you were communicating with an alien civilization across space, you could describe the Cobalt-60 experiment. Whichever direction the electrons prefer relative to the spin, that defines left, according to our convention. For the first time, left and right weren't just arbitrary labels tied to human bodies. They became directions encoded in the laws of nature themselves. It's a remarkable thought. Something as ordinary as the idea of handedness, something we use every day without thinking, is actually woven into the deepest structure of physics. Yet for mirrors, the story remains beautifully simple. The glass doesn't know about parity violation or particle physics. It just reflects light according to geometry. It swaps front and back because that's what reflection does. Everything else, the confusion, the imagined rotations, the sense that left and right switched places, comes from the way our brains interpret what we see. And this is where the puzzle becomes more than a curiosity about mirrors. It becomes a lesson about perception. Physics tells us what happens in the world. Psychology tells us how we interpret it. And sometimes those two don't line up. The mirror hasn't tricked us. We've tricked ourselves. So now we come back to the original question. Why does a mirror seem to flip left and right, but not up and down? By this point, the answer should feel almost obvious. The mirror doesn't flip left and right at all. It flips only one direction, the one perpendicular to its surface. Everything pointing toward the mirror points away in the reflection, and everything pointing away points toward it. That's it. That's the whole physical operation. The confusion happens afterward, inside our own heads. When we look into a mirror, we don't just see shapes and colors. We see a person. We recognize a face. And our brains immediately perform a silent mental trick. They imagine what it would be like if a real person were standing there facing us. And the only way a real person could end up in that position is by turning around. That imagined rotation swaps left and right relative to us. And suddenly it feels like the mirror must have done the flipping. But the mirror never rotated anything. It simply inverted front and back. The rest of the transformation exists only in our interpretation. Once you understand this, a lot of everyday observations snap into place. The reversed lettering on an ambulance makes sense because the letters were rotated to face you before the mirror reflected them. A double mirror restores the image because two front-back inversions cancel each other out. A mirror on the floor flips up and down instead of left and right because the perpendicular direction is vertical instead of horizontal. Every case follows the same simple rule, and that simplicity is what makes the puzzle so beautiful. There's no hidden mechanism, no secret mirror intelligence choosing directions. Just geometry and light behaving exactly the way physics says they should. But the lesson doesn't stop with mirrors. This little puzzle is really about how easily our intuition can mislead us. Our brains evolved to navigate a world of moving bodies, social cues, and survival decisions. They weren't built to analyze coordinate transformations or optical geometry. So when something unfamiliar happens, like seeing our own face reversed, our minds reach for familiar explanations. Sometimes those explanations feel right, even when they're wrong. Physics asks us to slow down and check, to separate what we think we see from what actually happens, to test our assumptions against careful reasoning and experiment. That habit of mind, the willingness to question intuition and follow evidence, is what lets us understand not just mirrors, but the entire universe. It's also what makes science so satisfying. The answer to this puzzle isn't complicated or technical. It's clear, almost inevitable once you see it. Mirrors reverse front and back. Our brains imagine a rotation. The apparent left-right flip comes from us, not from the mirror. And that realization has a wonderful side effect. It reminds us that the world is often simpler than it appears. Complexity frequently lives in our interpretation rather than in nature itself. So the next time you stand in front of a mirror, take a moment to notice what's really happening. Light leaves your face, bounces off the glass, and returns to your eyes. The geometry is precise, predictable, and beautifully straightforward. The person you see isn't flipped left to right. They're simply a front-back inversion of you. Everything else is storytelling your brain adds on top. And maybe that's the deeper takeaway. Understanding isn't just about memorizing answers. It's about learning to ask better questions, to look more carefully, and to notice when intuition quietly smuggles in assumptions. The universe doesn't rearrange itself to match our expectations. But if we pay attention, if we test our ideas instead of trusting them blindly, we can learn how it actually works. One puzzle at a time, one mirror at a time. Now I'll leave you with a thought. If something as ordinary as a mirror can reveal how perception and reality can diverge, what other everyday experiences might we be misunderstanding in the same way? What other things feel obvious only because we've never looked at them closely? Think about it. And if this explanation made something click for you, or if you've got your own way of visualizing it, share it in the comments. Because physics isn't just a set of facts. It's a conversation about how we make sense of the world. And maybe that's the quiet beauty of this whole mirror puzzle. It starts as a trick question about left and right, but it ends up revealing something deeper about how we understand reality. The mirror never fooled us. Our own expectations did. We assumed it must be swapping sides because that's how we imagine bodies moving in the world. But once we slow down and look carefully, the physics is almost embarrassingly simple. Light reflects, depth reverses, nothing else changes. That realization is more than just a neat explanation for a party riddle. It's a reminder that the universe often works in clean, consistent ways, even when our minds wrap those workings in complicated stories. Science isn't about memorizing surprising answers. It's about learning how to peel away those stories until only the underlying mechanism remains. When you understand the mirror, you're practicing that skill. You're learning to question assumptions, to separate observation from interpretation, and to notice when intuition sneaks in a step that nature never actually took. That habit doesn't just help with optics. It's the same habit that lets us understand atoms, galaxies, time, and everything in between. So the next time you pass a mirror, don't just check your reflection. Think about what's really happening. Think about the photons bouncing, the geometry of space, the simple rule that flips only one direction. And remember that sometimes the biggest insights hide in the most ordinary places. If this made something click for you, tell me what moment did it. Was it the glove example? The coordinate system? The idea that the mirror is innocent and our brains do the flipping? I'd love to know. Because physics isn't just equations, it's a way of seeing. And once you start seeing this way, even a mirror becomes a doorway into understanding how the world truly works.